Alright, today we look at resistance. Resistance of a conductor is the ratio of V to I. So say for example we have a wire here that is in orange color in my diagram drawn. So current passing through it is I, and we have a voltmeter connected across it to measure its potential difference. So the value from the voltmeter V divided by the ammeter reading, that will be the resistance of these particular parts of the wire. Okay, R equals to V over I, and it is actually the measure of opposition against the flow of free electrons, as we know that inside the electronic circuit, when current flow is actually the movement of the free electrons. They are drifting across the wires. Okay, so how is this equation derived? We have to trace it back to the Ohm's law that says that if you have a conductor with constant temperature, the current will be proportional to the potential difference across it. Okay, I'm going to skip this part here and we move on to the concept of resistivity. So we continue on this slide, the concept of resistivity. Before we proceed to look at what is resistivity, let's look at the resistance again. We know that it's defined as the V to I, but if we look at it carefully at the wire just now, actually the length of it and also the diameter of it actually will affect the value of the resistance. So how is it dependent on these two properties? Is that R will be directly proportional to the cross-sectional area, and R will be inversely proportional to the cross-sectional area, and it will be directly proportional to the length. So we have R directly proportional to the length and inversely proportional to the area. The longer wire you have, the bigger the resistance it is, and if you have a thicker wire, then it will be smaller resistance, and thinner wire, that will be a smaller resistance. Okay, a bigger resistance, sorry. So just like the diagram showing you here, those the orange color here, orange color particles here, they are actually the electrons. Imagine them as the electrons. So if you have a larger cross-sectional area, means that more of them can flow past a certain point in the same time compared to the one with the thinner or the one with the smaller diameter. So you can see that there are only a few that can pass through at a certain time. Okay, so resistivity R equals to rho L over A. You can see the rho here. This is actually the resistivity. Okay, so we have the proportion just now, R directly proportional to L, inversely proportional to A, making it into an equation. We add in the rho. So the rho basically is the resistivity. And what is resistivity? It is actually a property of a certain material. Okay, though it also means that it also in a way measure the resistance of a certain, describe the resistance of a certain material, but it has some difference from the resistance. Okay, so you have to be clear about this. The comparison between the resistivity, the difference between the resistivity and the resistance R. Okay, R dependent on L and A, whereas resistivity is a property of the material, which means that it only it changes when you have a different material. Okay, it's constant for the same material. Okay, an additional note to that is that actually it's also dependent on the temperature, but it's not dependent on the L and A as of the resistance. Okay, so it's measured in ohm meter. Here are some example: copper, concentrated wire, and mercury. You can see that they are around 10 to the power of 8 to 10 to the power of negative 9. Okay, so around that. You can see some is even negative 10. So around these values here, you can just remember that it's around 10 to the power of negative 9. Okay, so let's look at some example. What length of constant wire of diameter? This is the diameter. Has a resistance of 10 ohm. Assume that the resistivity of the constant is 5 times 10 to the power of negative 7 ohm meter. This is negative 7, slightly lower. So we have A equals to pi d square over 4. Pi d square over 4. That's the assuming that the wire is always a circular shape in its cross-sectional area. So we have 4 times 10 to the power of negative 4, and you divide by the 2 means that it's already converted into the 4 here. Okay, it's pi r square. Pi r square means pi d over 2 square, so we have pi d square over 4. Okay, let's move on. So once you got that area, now we have the r equals to rho L over A, and rearrange that, you get the L in front and you sub the values in. You should be able to get the answer as 2.5 meter. Okay, one more. We have a length of wire 6 meter, resistivity, so that's the L, R, that's the rho, that's the L. Always identify the quantities in such a way. And cross-sectional area is A, and look at the unit very carefully, it's in millimeter square. Calculate the resistance of the wire. Okay, calculate the resistance of the wire. So we can have R equals to rho L over A. So it's inside there, 10 to the power of negative 8, and then you multiply the 6 meter, and then you multiply the 0.25. So it's in millimeter, change to meter, that will be 10 to the power of negative 3 and a square. Okay, due to the square there, then you should get the answer of 0.41 ohm. So this one will be your assignment question. Okay, I give you the answer. Okay.